Hi guys, in this lesson I will talk about the key concept in kinematics. So let's start with acceleration. You need to know relationship between I, x, t and v. There are four different equations you can use for acceleration. When you see a problem, you need to know how to identify which one is appropriate to use. For equation of motion, so we have four of them. Keep in mind that they can only be used if I is a constant. So I cannot depend on anything else. When you got two objects, and if you want to work out where they collide, so you need to check whether they have the same x and y coordinate at the same time. Crossing path is a little bit different, okay? Two objects could cross paths but do not collide. So what happens is, so when they cross paths and they do not collide, so they have the same x and y coordinates, but these occur at different times. And when you see a question that asks you for direction of travel, so you want to work with the velocity vector, not position vector. So think of direction as the radians. So in this case, you got a position vector of a particle, and we only got the I and the J components, and they both depend on t, the time. And then you got another object over here. Again, you're given the position vector, and you need to work out whether these will collide. So very straightforward. You just let x of this to be equal to x of this one, and then you solve for your t value. Similarly, you let the y of this to be equal to the y of that, and you solve for t as well. In this case, you can see that these two t values are the same. That means they do collide when t is equal 1 over 3. Velocity time graph, you need to know how to read off the information. Velocity time graph give you a few things. So they give you the distance traveled and also displacement as well. So you need to know how to work out the area. So if you add up the magnitude of all of these intervals here, you should get the distance traveled. But if you just add up the side areas, you will get displacement. So in this question here, we need to work out the time taken for the object to go back to the initial position. That means the displacement would be equal to 0. Keep in mind that x is the displacement, so x is the position, x is not the displacement. So if you want the object to go back to the initial position here, you want this area to be equal to this area for some given time, and you need to work out what that time is. So note that in this case here, I just trade the areas to be positive, yeah? You want to make this equal to that. So this area would just be the integral of this function here from 0 up to 4, and this one here, you go from 4 up to some t value, and we call that I in this case. You want to make these two areas to be equal to each other and then solve for I. So we did talk about the forms of acceleration before. So take a few moments to read through the question. So in this case, I depends on V. And you want to work out the displacement of the particle between these two velocities. So between 2 meters per second and 3 meters per second. Since you are given I in terms of V, and you asked to work out displacement. So that's why you want to use this form here. because you have x in it, and x is a position which will give you displacement. So the first step is to identify which form to use. And after that, you need to do the separation of variables. You have two variables here, the v and the x. So you have to separate them out. So in this case, just brought the x to the left hand side, and I brought v squared plus 1 to the right hand side. So think about limits. So your v goes from 2 to 3, and then your x goes from x1 to x2. Okay? On the left hand side, if you integrate, you will get x, and then you sub in the limits x1 to x2, and that would be your displacement. So in this case here, you just have to evaluate that on your cast to get your displacement.